Hey, welcome back to the show, everybody. This is the Routing Loop, and I'm James Wenzel. Everybody calls me Jamie. And we're here to discuss some pretty cool features that have been launched recently. Just want to remind everybody who's watching that this show, the whole purpose is to talk about AWS networking, building on AWS networking, all the cool, fun things we can do with it. And today I am joined by Amar Latif. Amar, why don't you tell us who you are, what you do, and what are we going to be talking about today?
Hey Jamie, thanks for the intro. So my name is Amar Latif. I'm a principal architect in AWS. I focus quite a bit on networking and telco, and I have a heavy networking background, as most of you guys are joining here. And we'll be sharing some exciting things that we're introducing to the AWS cloud as far as networking, specifically dynamic networking.
Dynamic networking. Now, this is something that has been asked for quite some time. Like, well, how come you guys don't have dynamic routing? So, what can you tell us about this? What are we looking at here?
So we can get into the slides to describe, but on a high level, the currently today, as today, the routing within AWS is specific to network interfaces and specific IPs, and what we're introducing today is the concept of utilizing dynamic routing protocols, specifically BGP, to allow to influence routing within a VPC. So influencing routing within a VPC using known, well-developed protocols such as BGP. What are the use cases for that? We'll go through that in the presentation.
All right, perfect. Yeah, BGP is most folks know is like our routing protocol of choice. We use that also on our TGWs. We use that for Direct Connect. We use that for VPN. So why change it, right? Why would we want to deviate from something that is more well known? Um,
Correct.
should I pull up your slides and we should get going, or
Let's do that.
all right? And folks, just keep in mind any questions that you have, anything that you want, please pop it up in the chat, and I'll be sure to bring it to Amar's attention, and we'll do our best to answer you.
Beautiful. So as you can see, it's a new service that was recently announced in March of this year, and it is called Amazon VPC Route Server, which again introduces this dynamic routing within the VPC. So to Jamie's point, we had dynamic routing in DX, we have routing, BGP routing in TGW, but within the VPC, the construct here is within the VPC. So let's go through what do we have today in VPC. So today in VPC, what we have is, let's assume you have two instances, network function one, NFV1 and NFV2, and they could be in separate availability zones for high availability. In a typical VPC route table, you could have a route that points a virtual IP into a specific ANI, in this case, NFV1. So what this is doing is any traffic that goes to this virtual IP, and again, virtual IP is a concept that we in the networking space have been using heavily, right? A loopback or a virtual IP. And we point that virtual IP into the ENI of the NFV1. So what this means is traffic going to this VIP will go to this ENI. VPC will send the traffic to this ENI. So now let's say you want to fail over. Let's say you want to fail over. Something happened to this NFV and you want to fail over the traffic. You want to fail over the traffic from this instance to this instance. Today, the way to do that is issue an API to update this route table and switch the routes into ENI for NFV2. So that the API call here will come to the VPC route table and will update the virtual IP to point to this ENI. Once this is done, and it takes a couple of seconds, updates the traffic will be sent to this NFV, and this NFV could be in a separate availability zone. So this is the mode of operation today for failover of traffic that is destined for virtual IPs, this failover between instances. There are a couple of other modes also that we can use, but we're focusing on this mode. Now, a reminder before we go, okay, so how do we do this, and how do we go about this? We have an option of putting these NFVs behind an LGW, which I'm not showing on the screen here, but gateway load balancer, apologies, not LGW, gateway load balancer. We could put these NFVs behind a gateway load balancer and then have the gateway load balancer handle the switching of the traffic. That is a known pattern. It is supported today. This is what we recommend. What we're talking about here is, what if you have a network functions, let's say firewalls or DDoS appliance or what have you, that might not be integrated with gateway load balancer. Or, for example, you need a specific feature that needs to be deployed without a gateway load balancer. So what do we do in that case? All right. So again, where gateway load balancer is the lead mode of introducing NFVs. But if this cannot be supported today, what can we do? And so now the question is, how can I influence changing, updating these routes dynamically within the VPC? Dynamically meaning when this NFV fails, or when we want actually to attract traffic to this NFV, move it away from this NFV. Let's say there's an issue with this availability zone where this NFV is deployed. So that's where we are introducing the concept of Amazon VPC Route Server. The idea there is simple. We have existing protocols such as BGP that Jamie mentioned. And why can't we use it to communicate with VPC through BGP and do the routing updates through BGP? These appliances support BGP. It's a well-known protocol. Why don't we use it within the VPC to do that? So Jamie, should we jump now into the VPC Route Server?
Yeah. Let's do that. One thing I wanted to also point out too, just on your example, by the way, when you were discussing the gateway load balancer, you had mentioned one of the benefits of VPC route servers. You can handle these route shifts within the VPC. And remember, when we're using something like gateway load balancer, typically the gateway load balancer has an ENI in the VPC, but the mechanism is actually in a separate VPC. So here's another third-party mechanism that has an hourly charge, right? And you're basically sending it traffic. It's making decisions to its targets on the back end and then sending it back. So it's treating it more like a load balancer. We call it the layer 3 gateway, layer 4 load balancer. But that's not really addressing what Amar was talking about, where, hey, we've got a failure on one NIC and we need to send the traffic immediately to another NIC without having to build some sort of a Rube Goldberg machine of identifying when that NIC is down, creating an alert, going to CloudWatch, having a Lambda, having that Lambda kick off. And then the Lambdas also have a cold start themselves, so it won't kick off absolutely immediately, and then go back and then make an API call to change our routing table. Once that routing table change is done, everything is operating fine, and then it just stays that way. There's no way to go back. There's no nuance of what we're used to that are capable for things like BGP. So I just want to kind of layer that on top a bit too, just to let folks know that we really needed this to not be a complex use multiple services kind of thing.
That's right. So let's introduce a VPC route server. So let's build this slide. And VPC Route Server is an AWS managed service that allows instances, appliances in this case. It could be anything. It could be based on EKS, like Kubernetes based, could be virtual machines. It allows these appliances to utilize their BGP stack to communicate with the VPC route table. So communication with the route table, influence the routes, and do a failover also using BGP, using well-known established BGP. So in this case, what we're introducing is, if you think about it, control plane. Like the VPC Route Server is addressing the control plane portion. If you think about it, is like from a traditional routing perspective, it is providing us this RIB layer, right? Routing information base layer, which is collection of what is the state of routing around me from a BGP perspective, and then do the path selection, and then pass it on to VPC routing, VPC route table. Once it is programmed in the VPC route table, then VPC networking, our VPC networking handles the actual forwarding of packets. So you don't have a bottleneck in processing of packets. You are influencing the control plane. You are influencing the RIP. So in this case, if you notice, what we're saying is the BGP best path selection kicks in. It does the RIP calculation, and then it does update the VPC route table, which is the FIB in this case. The use cases here are active standby, switch over between availability zones. One more thing is interesting is we support BFD. So the service does support BFD. So meaning, our typical BFD deployment with 3 times 100 or 3 times 300 is supported for failover. So quick detection of a failure in the BGP stack and then do the failover. One more thing is we support updating routes in subnets, so a VPC route table and also an IGW route table. And let's revisit this towards the end because the IGW route table ties nicely with the new concept that was just introduced recently, which is ingress routing. Ingress routing. So this is basically traffic coming from the internet. So again, we'll touch on that later in the presentation. So traditional VPC route table as well as the IGW route table.
Nice. And just one question here too that I always get asked whenever we show off something cool like this. What about logging?
So logging is actually in CloudWatch. So Jamie, what you're asking for is, hey, how do I operationalize this? I mean, routing is good, but like, do we track any of this? And the tracking is actually using AWS logging mechanisms, CloudWatch, and CloudTrail.
Okay, good. And that's done on a per peer basis?
It is done on peer basis. So what you will see in CloudWatch and CloudTrail is peers coming up and down. When there is a route update, you will see all of that being tracked.
Perfect. Yeah, and of course, you know me, Amar, I'm always about automation too. So having all this in CloudWatch to be able to send like a notification or to do an action, very, very powerful. So it's actually one step above of what we're normally used to with the BGP protocol. And then one last thing too, you may or may not know, is this IBGP or eBGP? Or does it matter?
That's a good question. So here the question is, let's put it in perspective. This is within a VPC. So typically, if you notice here, when we said eBGP here, is why? Because we're trying to say, hey, these are typically in different ASNs, and there is so far what our deployments is all eBGP based. Can we do the same ASN? To be quiet, I'm not sure. To be quite honest, I can test it and report back. But it's typically eBGP because these are two separate routing, not domains, but like routing administrative domains. Yes.
Yeah, admin domains and yeah, entities, if you will.
Entities, exactly, because this belongs to VPC, and these are network functions. These are firewalls that could be managed basically by the security team, for example.
Sure. And then also, keep in mind between just to lightly touch between IBGP and eBGP, there's more. I would say there's a bit more guardrails and controls on eBGP as well in terms of security, making sure that you don't have any cross-zone jitter, any of that stuff, and just about anything that we're using, right? If you're using a VPC and to you as a customer, you're like, but this is internal. Just keep in mind to the route server, it's not. Right? It's an external thing that we need to treat with a very high level of security, a very high level of security zone. We don't want to give all of the standard controls for the IBGP because quite honestly, at this point, they're not needed.
Very true. Very true. In fact, it is very true, Jamie, this perspective. Um, and so the other thing is, if you notice here, the deployment is route server is deployed outside of the VPC, right? Just like any other AWS managed service is deployed outside of the VPC, but it has an endpoint that is deployed within the VPC, typically even within the subnet, but doesn't need to be within the same subnet. And basically this endpoint the peering happens with this endpoint. The peering, BGP peering happens within the and with this endpoint, and the BFD runs between the instance and this endpoint. The other thing is we deploy typically 2 endpoints per subnet for high availability because it's an AWS managed service. So you want to manage the updates, the patching of the service, and you want to maintain high availability through deployment of 2 endpoints. We recommend
At minimum. Yeah.
At minimum, yeah. All right. So let's get into a quick demo. I think a demo would be helpful here.
We love demos.
Yeah, rather than just looking at slides, let's do a quick demo. So let me just pull in. Let's pull in. So full transparency, I've been recently I'm a convert to generative AI, guys. I'm at home convert to generative AI, and then I'm at work increasingly a convert to generative AI. So I use it quite extensively nowadays in my work, and I just pulled in Amazon Q. What I'm sharing here is Amazon Q, and I'm going to use it to deploy and manage route server. So let me deploy, and then we'll discuss what are we deploying. So as you can see here, I started Q, and then I asked Q, give me where is the cloud formation for deployment. So it's giving me all the cloud formations available, and then it's saying, hey, which one do you want me to deploy? So let me just say this: deploy in East 1. Let's do that. And then it is thinking, and then it will ask me some. See, it's basically it's even detected. It's US East 1. Like, all right. So let's do this. Trust it. So what's going on in the back end is that see, it deployed the stack for us. You see, I didn't even need to worry about like opening consoles or remembering what's the AWS CLI for deploying a cloud formation. I have a cloud formation, it deployed it, and then it's saying, hey, this is how we can monitoring it. And I will not even I'm too lazy, so I will say check now. And then it will go and it will check the cloud formation, and of course it's still deploying, but I'm just sharing here. It's basically checking, and it's saying status, create, and progress. All right, so let's park this for now. And then let's go back to our presentation, and let's see what are we deploying. So what are we deploying is basically this use case, which is, let me build it out. Sorry, let me build it out. Like pretty much this is what we are deploying. What we are deploying is a VPC with 2 availability zones, and then 2 network functions, 2 instances representing, let's say, a firewall A, firewall B. And then we're deploying a route table, and we are deploying a full route server with 2 endpoints, one for this NF and one for this NF. It's also what we're deploying is a test instance here. I'm not showing it. That basically will attach to, will basically try to connect traffic to NF1, and then we do a failover to NF2. That's basically what we're. So let's deploy this, and then we will do this failover in action.
Real time,
right? And then we can also check. So what does this route server look like, right? So this is basically what we will do. We will basically, let me build it out. We will do the failover, so basically, I'll shut down this instance. This eBGP will go down, and then we will see that the traffic will be sent to this NF after a couple of seconds. All right, so let me let me switch back.
Check in with our demo, see how it's baking.
Yeah. All right, check again. All right. Okay, it's still creating. You can see what it's doing. It's basically creating all the IAM roles, but mostly it's deploying the VPC Route Server endpoint. Now, while we're waiting, Jamie, we have the link to the GitHub where maybe we can add it to the chat for people. What we are
There we go.
deploying here, that cloud formation is actually in GitHub basically, and Jamie has a link for it.
Yep, we got actually our producer put it on for us.
Beautiful. Beautiful. All right. And this is basically this is what we are deploying right now. What we are deploying right now is this is the layout.
Okay.
And the cloud formation template is actually in here, and it will take you through. So if you go through this, it will take you through how do you set it up and test it.
So
All
one
right, so
question
let's
I have
go
for you,
back.
Amar,
Yeah.
before we check back, is
Yeah.
other than firewalls, what other use cases have you seen this being used for that Route Server helps out with? Give us some
So
context.
good question. So in telco space, as you can imagine, so for example, in 5G deployments, a lot of network functions there is around again such deployments where the network functions, such as for example a 5G core, you for failover. So for deployment in the cloud, it becomes really easy to do that. DDoS mitigation. So engines that does specialized DDoS. So specialized DDoS, maybe you're doing like some L7 specialized processing of packets. Same thing. You will do that in here. These are like the 2, 3 use cases that I've seen it being utilized for.
Nice. And obviously customers are happy with it. It's doing what they need.
Yeah. See, what it simplifies is because now you are using BGP, it allows you to utilize software stacks right off the shelf without much updating, and also you don't need to now do custom routing, so it saves a lot on cost and complexity. You are relying on AWS native networking to handle packet processing, and you are relying on AWS networking to handle routing updates. So again, implementation of software becomes much easier this way. And yes, this is in production in many customers, at least that I work with.
Oh yeah, definitely. And now, does the Route Server accept BGP updates from other sources?
Tell me a little bit more.
So, like for instance, if I have one of those peers and they have a BGP update that they want to send to the Route Server, and then the Route Server will go ahead and shift the routing based on what it sees outside of a failure.
Correct. So let me step back. What you're calling out is, hey, I get it. BGP reset, a session reset is a good reason for an update. But is there other reasons that would trigger a route update outside of just a BGP session going down? And if I pull back the presentation, sorry guys, see here. So to answer your question, Jamie, what we do, for example, is it follows the same BGP logic. So we can update, for example, administrative path. We can do we can append basically ASNs, and the route server will calculate the new updates if we find, for example, a shorter path, ASN path.
Okay. Yeah.
So it
So
will dynamically update basically.
perfect. Yeah. One of the things I was thinking too is like sometimes if you have a couple of paths, right, and they're going through EC2 instances, and this is a little bit related to what who is Shafat is asking. Any small change will trigger an update. So, like, let's say you have on these ENIs, these peers that are peered up, some metric within your application that says I can't take anymore, right? Let's say it's not necessarily a routing thing as much as it's a compute thing, or I'm running out of cache, or my application just for whatever reason isn't working the way it should be. It can go ahead and say, you know what, I'm not going to accept anymore. I'm going to send to my peer, give them an update. I've had enough, send it to someone else. Is
I
that
like that very much. So this will, like, let's say, I'll take it a step further. So what you're saying is, hey, this virtual IP is being sent, advertised here with normal AS, and here we did AS prepend. And if you notice here, what we're showing is three AS being prepended. What we could do, and Jamie, to track on what you were saying is, we could change this advertisement from this NF saying 4 AS numbers, and then BGP would fail over the traffic to this instance.
correct? Yeah, exactly. So that's, I mean, I can't stress how powerful that is, right? Because now you're basically giving the ability for something, not necessarily networking, something on the device that's receiving that traffic to gate itself and say, hey, other than shutting itself off, which is never ideal. You could basically say, hey, here's the situation. I need this to be sent over. And I've had plenty of customers who actually are looking forward or have started doing these things. And for them to do it outside of the means of route server, it takes quite a bit,
It
right? I
does.
mean, you have to have something in your logs that you're logging in. You have to basically send it somewhere. It has to be
That's right.
captured.
That's
But
right.
instead, here you could just basically say, seeing how I'm part of a BGP peer, let's send a BGP update. Let's say, okay,
Yep.
let's prepend myself down to the point of
Yep.
irrelevancy, and then let something else handle. And then when I'm done or everything is good, I can move it back. And this,
I like
you've got
that.
an example here
Yep.
of two, but
Yep.
we can have
Yep.
how many endpoints can we have for route server?
So route server we could increase I think per subnet the default limit is 2, but we can increase that.
Okay, so you could almost create a small fleet
Yeah,
of
yeah, yeah.
these things that are aware.
Yes, yes.
And I like what who is Shafat is saying. Also, there's a bonus, right? Added security and redundancy.
Very true.
So
Very
your
true.
routing mechanism is not coming from an outside source. It's basically coming from the source itself. And
Correct.
then you have the ability to fail back and fail over depending on the awareness and the health of your app. But I will
Correct.
say that you need to make sure that you program that correctly within your application. You don't want to shift the problem, is what I'm saying.
Correct. 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 That's very true. All right. Let's check back on
Let's see how the
how are
pie
we
is baking.
doing. Yeah, how are we doing? Okay, generative AI. Don't. All right. Let's see here. So
Who is Shafata did ask one other question, which I'll ask too. He says, "Is there no limit to how many we can create?" We set a soft cap at 2, right? That's to make sure that everything is good. If you want to increase beyond 2, then what you would do is you would send you basically do a ticket and say that we
correct.
need to have this increased. Though it is
Correct.
really encouraged that when you create those tickets to say, "Hey, I need 4 or I need 5," just put in
Correct.
like a small justification of like, "Hey, this is what we're trying to do." We're not telling you or asking you to expose your secret sauce. We're
Yeah.
just asking that we have an idea of what you're doing with the service. So if there's any help we can give you, we can. But yeah, you can certainly increase it beyond the 2 that we have.
Beautiful. So the deployment is finished. If you see the CloudFormation is saying, hey, the endpoints are these. So these endpoints are basically, if we go back to the presentation, these endpoints are basically 2 here, 2 on this side, and then 2 on this side. So total of 4. 2 on this subnet, and this is one availability zone, and then 2 on this subnet, which is on this availability zone. And then we deploy 2 instances, and it peers basically with both endpoints. All right, so let's go back and let's ask, tell me about the route server routing state. So let's see what it will tell us. And then it will basically now try to go into VPC, and then you see it will check the route server, and then it's basically it's getting details. All right, so it will tell you even like what the BGP peer state. You see how I really like this. Again, Jamie, I know today is not about generative AI, but I really find this to be powerful. It makes our life much easier. Look at this. It's giving you all the route server IDs. It's giving you the ASN number, right? And then it's giving you the number of peers, which subnet it's on, what's the ASN number here, and what's the status of it. It's up, and it's summarizing it for you. So now you can check quickly and say, okay, well, this one is down. Let me go troubleshoot it. And look, it gives you a summary. It gives you the VPC ID, the route table ID, and then it's telling you it detected distributed across 2 availability zones. All right, so this is good. BGP Live is so what it's saying here, BGP keep alive is being used. So what it's saying here for us is we're not using BFD here. And full transparency, I did not enable BFD because, again, the instances I have are running Go BGP, and I didn't have time to set up the BFD basically daemon add-on. So I use BGP Keep Alive, but we could enable BFD basically for this demo, and it's basically telling us this. So let's check the VPC route table for the prefix advertised. All right, so let's see. It will tell us what is being advertised. So, in fact, I should have asked it, give me the VPC, the route server route table. So I'll ask that. Now, again, you can see I'm mesmerized by how this is. Look at this. So it's giving you the current routes. Let's wait. So current routes. So look at this. This is basically what it's saying is, hey, this is the VPC route. Right? This is the default route going to IGW. And this is the route that we are sending from, you see, if you notice here, advertisements. So it is being advertised to us from a route server. From an endpoint, one of the 4 BGP peers, basically. It's advertising to us 172.16.11/32. This is the loopback IP that we are advertising. And it says, hey, advertisement this, its origin is from route server, and this is the peer that we are saying. So now, show me the route server route table. Let's see what it will give me. So it should show us that, hey, I'm receiving this route from all 4 peers, and I'm accepting only one. All right, so let's see. And then what I will do is, in the meantime, I can go in and, all right, so look at this. So look at this. What it's saying is basically the routes in the route server table it gives you the route server endpoints. We have 4 of them. Mm-hmm. And then the routes are, if you notice here, 4 routes, the same thing, being received. One of them is in FIB, which is this one, based on the Jamie. Guess what? This is the BGP secret sauce, right?
Yeah.
It selected this one, and it's saying I have these 3 in RIB because either it's a AS prepend is longer, or like a tiebreaker because these 2 are similar AS path. So it selected this one based on one of the tiebreakers, probably the loopback IP.
Right.
You see, and it's describing this to us.
And just to catch everybody up, RIB, route information base, stored route that the BGP knows. FIB, forward information base, is basically where it's sending the actual routes to.
That's right. That's right. So let me see if I can. So let me say, give me SSM information to log in to the test instance. I think that's what I called it. So let me get the SSM information, and then we can log into that test instance.
You can't just say log me into the test instance.
So it could do that. The problem is I don't know if it will give me the prompt. So I will prepare this.
I guess.
And let me see if I can start another one here. And basically, what happened here? Okay, it went. So guys, it went really small for us. Let me see. Where did I put the? Oh, it's this one. Okay, got it. All right. So you see, it gave me the SSM ID for it, and it says which one of them you want. So I'll access this one.
And it even gives you the command. That's nice.
Yeah, see, Jamie. Again, I'm like praising, right? Like, look how easy it is. So now
You're gonna
after you
convert me, I
see,
swear.
so you see how I'm connected now, and then let's do a ping 172.16.1.1. And it's basically replying. So where is this going? This is going basically, let me stop this. Let me go back here. This is going to one of these two instances. And it's actually this one, we know for a fact, because of the routing, because of the routing resource. So now what we could do is let's shut down this instance. So again, I will do this through shutting down this instance. So shut down, actually stop instance BGP peer NAZ1. I will not even give it the ID of the instance, and then
See how smart this is.
yeah, and see how
Look at
what it
this.
will do for us.
Boom. Matches.
Yeah, you see how it says stopped, right? It's stopping, was running. So now let's check VPC route table state. All right, let's see. So it should update. And look, it's even detecting that. See, it has a context. So it seems that our demo is generative AI and queue and less route server. So let me make sure. So here, what happened is that the queue is detected that we're doing the testing. So it noticed that ENI changed, right? And look, it truly changed because this went to 10.0.2. I know this one is on the second AZ. So it did, so look how quick the failover happened. And look, this is, by the way, this is Gen AI. I don't think this is coming from this is basically flagged by Q. And let's go back here and then let's continue a ping. And look, the ping is actually still happening, except the traffic flipped over to the
Second instance.
second instance, exactly, in a different availability zone, by the way. This is in a second AZ.
That's amazing.
Okay.
And it basically came up too as soon as you told it. It was like VPC route table state after BGP failure.
That's right.
When you asked for was like, show me the route table state.
Correct. And so this is again, this is Q. This is basically Amazon Q, which I personally Q for developer. I use it quite a bit recently. Like I switched about 2 months ago, and I'm not looking back. But having said that, okay, so let me pause here, and then let me pull. I can log into the console basically for us, and then we can do this. And guys, give me a second. So let's do the VPC here. And we'll go to the route server and just do quick tour of the route server and the console. Let's make sure we are in East 1. So I am in East 1. And let's go. I don't think I think I can zoom in a little bit, right, guys? Jamie, what do you think? Zoom in a little bit? Yeah.
There we go.
All right. So So you see this route server is new. So if we click on it, this route server was created, right?
Mhm.
And then it's basically saying, I will propagate. See this concept of propagation. So it's saying basically which route tables to update, right? See, at the end of the day, route server can receive let me just open it up. Route server can receive the routes, but what route table in VPC you want to control that? Like, because you want to say, okay, like sometimes you want to segregate the network functions per route table, right? So you
Mhm.
basically we're saying, hey, update this route table, and you could have multiple route tables to be updated. In this case, we're just updating this route table. The other thing is these are the endpoints that were created.
Now, one
And
thing I
yeah,
will just want to mention about what route table to update and all of that.
yeah.
A lot of times when we're working with any type of automation, I always give recommendations. And Amar, please chime in if you give something different. But when we're looking at routing, I always say the monarch or the king of all routing or the queen of all routing, depending on your perspective, is always the host itself, right? It knows where it wants to go based on its local routing table. And when the application calls to send traffic out, that's going to be number one. Number two, outside of that, is the subnet. And this is where you're going to now start controlling routes on multiple things at once. And this is where I typically recommend for your first line of routing is to put it at the subnet level, right? And then after the subnet, it will go to your VPC. And then after your VPC, it'll go to wherever your VPC points it to, like if you're going to a transit gateway or DX or whatever. But when you're having multiple, one of the powerful things about this having multiple route tables updated is if it were me, I know this is the demo, but if it were me in actual production, I would have route server updating my subnet routes as opposed to my routes in the grander route table, because my blast radius will be down to just the subnet for anything that I want to do as opposed to everything. Amar, what are your thoughts on
No,
this?
that's exactly correct. And in fact, blast radius is one, security is another. You might want just limit the access for these NFs to like a specific set of instances. So 100% on focusing on the subnet and segregate like subnets, put route tables around subnets. Exactly.
And most times too, that's what's bitten me in the past, especially when I was brand new, is that whole link localness of a VPC, right?
Yeah.
Like if you put in
Yeah.
two different CIDRs into a VPC, they can talk because they're considered
Yeah.
link local. And that's why I always like to
Right.
break things up to the subnet as well.
Right. Exactly right. Exactly right. And here you get the routes. And if you notice here, because we shut down the instance, we should have gotten four, but now we got only two.
Right.
And one of them is nrib. That means this one is not selected. This one is got selected, and this is it tells you here routes installed, which means it will tell you like what route table basically it's installed. And if we go to that route table, it will tell us this is what was uh, installed, and it will tell you this route is uh, propagated by route server.
And that's
So
another
this is
thing
the
that's really
dynamic.
important.
Yeah,
That's important too, just
yeah.
because that was one thing I wanted to talk about is that when we're starting to look at doing dynamic routing and routes are coming in and out, right? Knowing where the route origin is from is
Yeah,
very, very important. So if you
yeah.
have something that, let's say, for instance, heaven forbid, you incorrectly configured your route server to point to something it shouldn't, that would be one of the first places you want to look is like, okay, here's the route, where's the origin? And then that will lead me back to like, okay, this is the route server. I don't have to go crawling through multiple route tables.
That's right. That's right. That's right. The other thing is also, again, we are all networking gurus here. The dynamic. So what if I introduce a static route also in here? So the static route will take over the dynamic route, like
Right.
just like on-prem. What we do from routers perspective, similar here is you could introduce static route and it will basically preempt, followed by dynamic routing from BGP.
Yeah, exactly. Yeah, static routes are always. That's a good point too. I should add that to my whole diatribe of routes, static routes, and now dynamic routing is
Right,
secondary. So I have to keep
right,
adding that adage.
right. All right. So just for the benefit of time, uh, let's switch gear to one more topic, which is And then we can go back to the demo, but basically, so we did this failover. Another use case, where we see the route server is used, is this. So I built it out. So if you notice here, let's say you have service chain, which means you have a set of firewalls and a set of DDoS, for example, DDoS appliances, and or WAF, for example, again, whatever appliances you're using that maybe is doing something specific, like something unique that you really need to use these appliances, or like say a proxy, you're introducing a proxy. So if you notice here, in between these instances, we are using BGP directly between them. So this is nothing to do with VPC. You're just doing BGP crisscrossing between them to get traffic from the firewall to DDoS and back, and then from here to other instances. But what if you want to send traffic to the internet? So in this case, we have two options. You could force traffic for elastic IPs to go through the DDoS appliance using route server. So let's say you have an elastic IP, an instance with an elastic IP here, and then you want the traffic for this elastic IP to come through the DDoS before being sent out to the instance. So we could do that. Basically by, again, like, and there is a blog that we published recently on this topic on how to set up basically filtering of traffic from the internet destined for an instance, but force it to go through a service chain. Let's say, again, a firewall or a proxy. So we'll put a link to the blog in the chat. So that's one. The other is, well, what if I need to pull in not a single elastic IP? What if I need to pull in a set of IPs? What if I have a 16 IPs, let's say, a /28, or 32 IPs, a /27, that you need to send the traffic for all of that to an instance? And think now you are offering a service to your customers, and you really need to scale the number of IPs you are offering to customers. So you're attracting traffic, but you're sending it through an instance. And we've seen that. Again, there are use cases for it. So what do we call this within AWS? We call that concept ingress routing, and we'll give a link to that in the chat. So it has been recently announced, and ingress routing allows you to basically aggregate a /28 or larger /27, /26. You aggregate these public IPs, and then you send it to an instance. And that's an IGW feature. That's an IGW capability. That's why we're showing an IGW here. So IGW would be programmed to accept traffic from the public towards these public IPs, and it's an aggregate of them, and then send it to an instance. And that's where route server happens, is basically a route server gets the update from this DDoS network function. It is sending it. It is telling the route server, hey, send the traffic to me. And route server updates IGW. So again, route server can update an IGW for this use case, which is ingress routing, or it can update regular VPC route table. And this is powerful because now it opens capability for some customers, some of our AWS customers, again, who really have a bulk of like internet traffic coming to them, and they want more than just one elastic IP. They want set of IPs. Now, of course, we're not going to cover it here, but like the ingress routing is a feature on its own, and you require to be onboarding. Like you need to bring your own IP into AWS, you put it inside of AWS IPAM, and then from there you start cutting chunks, and then assign it to IGW. Again, it was not the intention of, like, I don't have slides on that. So, Jamie and I, we can talk about it if you have questions, but we're not going to cover it in details. Maybe we can cover it in some subsequent sessions.
Sure.
All
Yeah,
right. So
ingress
with that,
routing
yeah,
is a very powerful tool of basically forcing traffic where you want to go based on things such as the two-tuple source and destination. Um, and yeah, you could put it on the IGW, and we even have one called more specific routing, which can also be done on the subnet level. But yeah, Amar, that might be a topic that we might want to dive into, maybe some whiteboarding next time you're on the show.
that's right. That's right. That's right. So let's go back to the so let's go back here. Thank you, Q, for all your help. For your help. And then now let's shut down. I'll tell it to shut down the stack. Let it shut down the stack so it will clean. So now it will clean it up.
Q is
And
very
then
pleased with itself, with a demonstration. It already knows that the results are excellent.
that's right. That's right. I like it itself. It's happy. It is proud. This will take down this stack, and the final. I think we have final thing to do is basically the provisioning step. So if I pull this in here, let me see. Okay. So the route server provisioning steps is basically you create a route server and then you attach it to a VPC. So think like IGW, right? Like you create an IGW, then you attach it to a VPC, and then you start creating endpoints, and these endpoints are basically your BGP peers. Think about it as BGP peers. These are endpoints in a subnet, and you basically, and then so you have the endpoints in a subnet, and then you tell VPC route server to whatever routes you're going to get, propagate it to this route table or a set of route tables. So that's basically attach route server endpoint to a route table. That's what it means for route propagation. And then you create a peer. And this creating a peer is basically just like going into a router and you say, router BGP, neighbor, blah, blah, blah. This is the ASN number. This is the peer ID. This is the like basically the details of the neighbor. You create it again either through the console or through AWS CLI.
Pretty easy.
Yeah. One more thing, Jamie, is interesting. I was testing is route server can support also IPv6. So both IPv4 and IPv6 routes could be provisioned by route server.
Nice.
Because I know, like you know how increasingly we are seeing interest in
More V6.
IPv6, right?
Yeah,
Yeah.
yeah.
I don't know
Now,
if you
one
noticed that.
question I've got for you, Amar, as I'm asking loaded questions because I know the answer, but I'm asking on behalf of the audience. ASNs. Talk to me a little bit about the ASN. Does that have to be unique as opposed? Should I make sure I do a unique one? Because we need ASNs already for our TGWs and other things. Is it safer to do unique, or can I just copy? What do you suggest?
So as everything in life, right? It depends. So in this case, if you notice the route server here is local to the VPC. So it's a VPC local construct. So in this case, I wouldn't worry about it being unique. I would just use like whatever 65,001 or any of that, right? Because it doesn't like there is it's really local significance. There is no like interconnection between VPCs because that's not the intention of that we have GGW to connect VPCs. So to answer your question, because it's local significance, no restrictions on what ASN to use.
Perfect. Perfect. Yeah, that's good. That's a good point. And then I'll obviously, just for best practice, use private ones, right? Don't put your don't put your public ones, and not so much because of the fact that I'm worried that your public ones will have any issues. Just as Amar said, this is all localized to the VPC, but there is a certain level of security in that, right? You want to keep all of the private ones that you do any type of things you want. Anything public should be administered on a very prescriptive basis, and that's just ASN hygiene, not anything to do with route server.
Very true. Very true.
So, Amar, we're coming up on 5 minutes left, and this is generally the time when I ask our guests, and thank you again for coming and showing this awesome technology. What do you want the audience to take away of all the things that you've shown them here, what are the things that you want them to take away and to do after seeing this?
So definitely number one, Jamie, as we are all builders, right? So pick a in your account, create a VPC and experiment with Route Server. See how it applies to your use case. And again, it's not the only tool we have. Again, we have other tools, Gateway Load Balancer, NLB if we need to do some load balancing. But number one, start building, like start experimenting with what Route Server can do for us. And then it's very use case specific, very use case specific. So in this case, again, expand your tool lists and add this to your tool set.
Very cool. Very cool. Well, thank you again for coming on the show. And we'll definitely have you back again. Let's talk about, I love talking about routing. I mean, back in the day, you know, there was always the routing and switching. I was always the routing guy. So let's talk about some ingress and more specific routing next time and see if we can create a mess on a whiteboard.
Beautiful.
But that'd be great. And for everyone else tuning in, thank you very much. Please don't forget to put any comments in the comment section of what you liked, what you didn't like, anything that you want to see coming up, any future shows. And also remember that this is recorded and this will be on theroutingloop.net. So any of the shows that we've done before that we do every week on Thursday, same time, same bat channel. Usually it's 1:30 Eastern time and earlier than that on Pacific time. So thank you all. And then lastly, don't forget to play with Amazon Q. I think Amar's maybe a convert on this demo because I almost always get bitten by the demo demons, right? Where they're always screwing it around. But this one,
always, right? It's good.
Yeah, but this one is pretty good. This is pretty good. So I'm going to be definitely playing with that, and you all should too. And I think from there, we're going to end the show. Thanks a lot, and have a great day.
Perfect. Thank you, guys.